Hey, Will, thanks for joining me. So we're here to talk about fuzz testing or fuzzing. I'm actually not clear what's the best term to refer to it by. But what is it?
Yeah, so I guess I also am not clear what the best term is, but I tend to call it fuzzing. I guess fuzzing is like sort of a high level term for trying to throw random or like unexpected input at some program to try and find like bugs or behavior you hadn't anticipated or like edge cases that you didn't know were possible. So effectively, you're just trying to really exercise for a game to make sure that you kind of accounted for every behavior or to have by throwing lots of different inputs, sets of inputs at it. So it's really handy if you've got like a complex system where it's not just a case of saying, well, to test this function, there's like 5 inputs and 5 expected outputs. You know, there's actually billions of possible input states and billions of output states. So it can be handy for that kind of, over a period of time, building confidence that the system works as you think it does.
What kind of issues does that help us find?
Pulumi is a great example of such a complex system. So like, our job at its heart is taking programs that our customers have written and using them to manage, lots of state across multiple clouds and all these things. And, like creating a virtual machine in some cloud could fail, and it could fail like halfway through doing it, or like we could successfully create the VM but fail to record the fact we've done it. So there's all these like nasty intermediate states, and obviously that's multiplied by probably creating tens, thousands of resources. And at any given point, we want to know that if Pulumi succeeds or crashes, that we've left our record of where we were in a good state so that we can retry, or so that next time you run a Pulumi update, everything works. And so fuzzing is very handy for us in this scenario because it allows us to generate many thousands or millions of possible starting states and randomize, okay, let's try and create a new resource here or delete this thing here and fail halfway through the delete and all that kind of stuff. And sort of assert that when all is said and done, Pulumi is still left things not in a complete mess, basically.
So is it literally like trying random varieties of resources? Like nobody's ever tried to set up Fargate and then add and remove this bucket with a weird Unicode name, or?
No. It's less exciting than that. It is random combinations of resources, but the example you gave is a really lovely one. Like we could test like with real things, like let's try and create a Fargate cluster, say, but that would be really slow to try and run. Ideally we want to run millions of these examples as quickly as possible. So what we do actually is we fake the sort of cloud side or mock it up. So what we're really concerned with is if you've written a Pulumi program where you've said, I want to create, say, this user, and then I want to create this virtual machine that this user can log into, there will be a dependency between those two parts of your program. And, Pulumi's got a lot of power for expressing these kinds of dependencies. And the nice thing about Pulumi is that we will take care of those relationships for you. So if your VM depends on the user, we're not going to create the VM first because it needs the user in order to work properly. So what we're really interested in is if we set up some random program with a set of dependencies in it, do they get respected even if, say, one of the dependencies fails? Will the other things after it fail correctly, or will we still try to create them and break the customer's cloud, basically? So it's the relationships between resources that we're interested in. So generating millions of possible combinations of resources with different dependencies between them, and then running different operations. Like Pulumi's also got a lot of options for saying, I just want to update this resource, or I want to refresh the state of my Pulumi program by looking at what's currently in the cloud. And so all these different interactions can create bugs and edge cases that it's very hard for us to like consciously enumerate one by one. So fuzzing is very useful for that kind of stuff.
Yeah, it sounds like a hard problem. I assumed that, this is approached differently than like most testing. Like, it's not like, I assume you're not running this in CI as part of some like testing framework to like run a million interactions.
That's a great question. I guess, anyone who's familiar running like tests in their continuous integration knows how annoying it is if a test randomly fails and stops your sort of pipeline from going green. And I guess the whole point of a fuzz test is that you're hoping at some point it does randomly fail and you're like, oh, there's a bug there I didn't know existed. So yeah, it's a great question of should you run fuzz tests in CI? We're still working out what's best for us, but I think our current thinking is we would like to run them in CI, but not prevent people from merging work if we find a failure, and instead potentially raising an alert saying, we found an error case that someone should look into. But it's kind of a trade-off between, if we run them in CI, it means we run them more often, and every run should in theory generate an as of yet never seen before set of combinations. So you're sort of continually growing the set of the search space that you've explored. But yeah, we don't want to knowingly introduce flaky tests. There's definitely some salty how we handle those failures.
Purposely flaky tests. Yeah.
Exactly.
But like, I was also thinking of the time to run, I guess, being.
Yeah, so in Go, we use a framework called Rapid, which is actually a framework for doing what's called property tests, where you kind of say, instead of saying like assert that add 2 and 3 is 5, you would instead test a property. Like if I add any number to 0, I always get the same number. And then a property testing framework like that will generate lots of inputs and just check that the property you specified holds. I think there are a lot of overlaps between property testing and fuzzing, because effectively fuzzing, as we're doing it, can be turned into a property, which is if you start with some known good Pulumi state and you run a known legal Pulumi operation, do you end up with a known good Pulumi state that has no errors in it? That's basically the property we're testing. And so we ask Rapid to then generate, say, n possible combinations. But the point is, you can configure, most frameworks will let you configure how many like seeds, starting states you want to start with. So you can kind of tune how long you want the test to run by just saying. So for instance, if we know that we can consistently test 1,000 cases in 10 seconds, then we'll just, every time a CI pipeline runs, we'll test 1,000 cases. If on average CI takes 5 minutes, then you might try and run 100,000 cases every CI run. But there's kind of that tuning that you could do. But equally, if you wanted to run like 100 million cases, then maybe you would set up some sort of scheduled job just once a week. Let's just run the fuzzer for an hour off in the background somewhere and have it post alerts if it finds anything. That's potentially another way you might look at it.
Yeah. I'm excited that you mentioned property tests, because I was a Scala developer. We use property tests a lot. And then I started doing Go stuff, and like it seemed like nobody had heard of it. And then it turns out fuzzing is like, it's almost just coming at the same problem from two directions, right? Like property tests, you're like trying to find some sort of invariant that you can like make sure holds. And then the fuzzing kind of comes with just like throwing lots of random interactions at it, looking for crashes maybe more than properties. Yeah, they seem very related to me. But yeah, maybe you can show us something that you've done.
Yeah, I will. I'll start with one I prepared earlier, because obviously it could take a while to find an error case. And, this is a sort of a deliberate bug I've inserted just to illustrate it. But so as mentioned, like Pulumi is written in Go. And so our fuzzing tests are written just as normal Go tests. So if you're familiar with how Go is tested, you might recognize some of its output. But effectively, we have a test I've run, and the fuzzer has found an error, in this case, that we sort of inserted for the purposes of this demo. And when it finds that error, it prints out the state that was randomly generated in order to reach that error. So this isn't, the exact details aren't super interesting, but the rough view of it is the things in your cloud we call resources. So every Pulumi program is made up of some resources. And as we discussed a bit earlier, the question we're interested in is like, if resource A depends on resource B, and we run some operation, do we still, do we preserve that dependency? Do they appear in the right order? That kind of thing. So here we found a case where that's doesn't end up being true. And so we've printed out, here's the set of resources we started with. They're URNs, which is Pulumi's sort of fancy term for like the unique identifier for each resource, are color coded. So you can kind of see this resource has a parent that is this red one here. And so there's a relationship here. And this resource is provided by this yellow provider here. And then we also spit out the program we ran. So when you actually run Pulumi up, for instance, we run, say, your TypeScript or Python program, and that tells us what resources you would like to have. And we compare that against the state you actually have and work out what the difference is, right? So again, here we generate a random program. We generate a random set of, deletions of this resource are going to fail. If we diff these two resources to work out what the changes are, we're going to indicate that a replacement needs to happen, that kind of stuff. But the end result is, as an engineer working on Pulumi, we get told, if you plug this into Pulumi, you will find a bug. We also do some nice stuff, like we generate a piece of code that will help you reproduce that bug just in isolation and that kind of thing. But that's kind of the heart of it, to your point. Like we found a counterexample in the property testing lingo, and from there, hopefully you can work out what's actually gone wrong.
So it's actually
the alternative, which is trying to think of scenarios you think will break, which probably works when you're early on in the project. But now that Pulumi is quite mature, we really are hunting for some of the finer edge cases.
So it's actually, like a property that you found. This isn't like a crash. Like when I was thinking of fuzzing, I was thinking of like people hunting for crashes, but you've actually found some sort of like, invariant that's been violated by the...
Yeah, I mean, the reality is the invariant we're looking for is that we call it a snapshot, like the state that Pulumi writes out when it's done passes an integrity check of some sort. So every time Pulumi sort of records what it did, it writes out the list of resources and they must appear in the right order. Like you can't depend on something that hasn't been mentioned yet, that kind of stuff. And so we call this like an integrity check. And so the invariant we're looking for is that do we always produce snapshots that pass the integrity check? It doesn't result in a crash, but if we did write a snapshot that fails integrity, Pulumi will throw an error. So again, it's very similar. Like the program is not sort of hard crashing like a segmentation fault or something, but it's kind of hitting an error case we're aware of, but we really expect not to hit, if that makes sense.
Yeah, no, it totally makes sense. I mean, it's much, it's better. Like you can find, these are very important issues to find, right? They're not crashes, but
yeah. I mean, the bonus is if there is an actual crash, like in Go terms, like a panic, we've caught a few of those this way as well. They're hard. If we get a panic, the tests will crash as well. So it's slightly harder to reproduce, but in that sense, fuzzing does tell you that there are routes which can still produce panics. So we get a little bit of that for free if we've been particularly reckless with some of the code.
So why does this matter? Why should, users of Pulumi care? Or
I think, like, if you're using Pulumi, you are ultimately placing a huge amount of trust in us. Like, you're trusting us to manage your infrastructure, which is kind of, for many people, it's the base layer of whatever they themselves are doing or offering, right? Like, if you're a SaaS, your cloud infrastructure is what enables you to serve your customers and that sort of thing. So, like, it's really important that we get that right. Like, you can't have confidence in a tool and have it let you down by saying, well, I've lost track of where I think your cloud resources are. You're going to have to manually patch them up, which is ultimately what will happen if Pulumi's state is invalid. Don't get me wrong, these bugs do still occur, and we're at the point now where they're relatively minor, but they're still annoying, right? The whole point of Pulumi is to take that problem away from you as our customer. So, we want to get to the point where we're kind of more proactively confident that you're not going to hit these kind of nasty errors. And that generally, like, if you do something, if Pulumi up lets you express some operation, that operation should always succeed in a way that keeps you in like a good state.
Yeah, that's amazing. All right, Will, I'll let you get back to it. Thanks for your time.
No worries. Thanks very much.